This video, I'm going to reveal the top 3 Taylor series of all time. The number 1 best Taylor series of all time, in my opinion, is the Taylor series for e to the x. I'm going to center all of these Taylor series at 0. So e to the x has Taylor series, the sum going from 0 to infinity. If you want the Taylor series, you take n derivatives of your function, plug in your center. In this case, I'm plugging in center 0, divide by n factorial, and then I have x minus the center to the n. Now, derivatives of e to the x are e to the x. If I plug in 0 for x, I get 1. So the series, the Taylor series for e to the x is the sum x to the n over n factorial. A very nice series. 1 plus x to the first over 1 factorial plus x squared over 2 factorial, and so on. Now, in our course, when we write down a Taylor series, we also are going to write down the radius of convergence. You could do the ratio test on this one. It's a routine exercise. You should do it if you're not comfortable with the ratio test. But if you did the ratio test, you would find the radius of convergence is infinity, meaning every single value of x you plug into this series converges. It also means that e to the x is actually equal to this infinite series. No matter what x you plug in, this equation is true. That's my very favorite Taylor series of all time. Number 1, e to the x. Number 2, the geometric series, 1 over 1 minus x. We saw this earlier in our course. This is the sum n going from 0 to infinity of x to the n. A very simple series, 1 plus x squared, and so on. Now, when we first discussed geometric series, we decided that the geometric series converges for values of x in between -1 and 1. The radius of convergence, this is the interval of convergence. So the radius of convergence is half the length of the interval of convergence. The radius of convergence is 1. That means if you plug in numbers in between -1 and 1, this function 1 over 1 minus x is this nice Taylor series. And then my last Taylor series on this list is one we saw in a previous video. Sine x. That's the series going from 0 to infinity, -1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. So if you write out some of the terms in this series, you start with x minus x to the third over 3 factorial plus x to the fifth over 5 factorial, and so on. You get the odd powers that alternate. Here, I think we decided in an earlier video that the radius of convergence, infinity. So these are the 3 top Taylor series. And I'd like you to know them. I'd like you to recognize these when you see them. So memorize them or something. There's only 3 of them. The reason? You could use these top 3 Taylor series to build more Taylor series without having to take a bunch of derivatives. Let's do an example. What is the Taylor series for 1 over 1 plus x squared? Now, if you'd like to find the Taylor series, of course, you can take a bunch of derivatives and do this thing here. However, an alternative, which I'm showing you now, is to take a known Taylor series and adapt it to the one we have here. So, what I mean, 1 over 1 plus x squared. That's 1 over 1 minus negative x squared. I changed nothing except I wrote this function to look like 1 over 1 minus something. I have 1 over 1 minus something. The Taylor series centered at 0 for that function is here. So this is the sum, n going from 0 to infinity, of minus x squared to the n. I just took this equation and replaced x with negative x squared. So that's the sum, n going from 0 to infinity. I could write this as minus 1 to the n, x to the 2n power. There, I have a new Taylor series built off one of these 3 building blocks. You can find the radius of convergence for this. So when you find a Taylor series, I'd like you every time to write down the radius of convergence. In this case, the radius of convergence is 1. Why is that? Well, this I used a geometric series to find. The geometric series is valid for negative 1 less than x less than 1. So in this case, I need negative 1 to be less than negative x squared, which is less than 1. In other words, the only values of x that satisfy this condition are values of x that are in between negative 1 and 1. So that told me that the radius of convergence was unchanged. Now, if you don't like this trying to relate back to a geometric series, you could, of course, use the ratio test or another test to decide the values of x that make this converge. Let's do another example to finish up this video. What about the function e to the x squared minus 1 over x? So let's find the series for this. Now, it would be horrible if you took this function, started taking derivatives and plugging in. It'd be a mess. You'd have to use the quotient rule, chain rule, product rule. It'd be disgusting. But you can use one of these top 3 series, ones that I expect that you know, to get new ones. So let's do it. E to the x squared. Let's write down what that is. So I have my series here for e to the x. I'm going to replace every x with x squared. So I get 1 plus x squared over 1 factorial plus, now I'm plugging in x squared, so I think this becomes x to the 4th over 2 factorial. The next term would be x to the 6th over 3 factorial, and so on. So that's the e to the x squared portion. Then I'm going to take that whole thing and subtract 1, and then divide by x. Okay, so 1 minus 1, those cancel. Then I'm going to take every single term in this series and divide by x. So I think I would get x to the 1st over 1 factorial plus x cubed over 2 factorial plus x to the 5th over 3 factorial. The next term, what would it be? I think it might be x to the 7th over 5 factorial. There, that's the series. Now listen, you don't have to write down the series in sigma notation if that's not comfortable for you. It's totally fine with me if you leave your answers like this. I mean, that is the answer. But just for practice, I want to rewrite this in terms of a series. It actually is sometimes convenient, even though you don't have to. It is convenient to write it in sigma notation because In that situation, it's easier to find the radius of convergence. So what's the series expression for this? So I'm going to start, why don't I start at n equals 1, because the terms start at 1. I could see I'm getting a 1 over n factorial. 1 factorial, 2 factorial, 3 factorial. Oops, this should have been 4 factorial, shouldn't it? 4 factorial. And then what are my powers of x? My powers of x are the odd numbers. So I'm going to do 2n minus 1. The power of x is 2n minus 1 because if I plug in n equals 1, then I want to get out 1. If I plug in n equals 2, I want to get out 3. So anyway, there's my series. You could find the radius of convergence. The radius of convergence for this series is going to be very similar to the radius of convergence for e to the x. It's equal to infinity. But you could always double check that by actually doing the ratio test or some other convergence test to decide. All right, great.